Hello viewers, welcome back to my channel. I hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of the problem such as breadth first search, depth first search, dynamic programming, trees, graphs and so on. So don't forget to check them out. I have uploaded the code for this particular problem to GitHub repository. You can find the link from description below this video. Let's jump into today's problem. Permutation in a string. Given two strings s1 and s2, write a function to return true if s2 contains the permutations of s1. In other words, one of the first string's permutation is the substring of the second string. So basically we are given with strings s1 and s2. So in s2 there is a permutation of s1, right? So if it is there, we need to return true, otherwise return false. So let's try to understand what is actually a permutation here, right? So here s1 is the string AB. I'm taking the same example as in example 1, AB, which is of length 2. Okay, so s1's permutations. So what are the permutations in s1? So AB and BA, right? So basically the permutation also have the same length and it also has the same number of occurrences for each character, right? So permutation is nothing but you are just trying to change the places of the existing characters. So AB is there, right? So S1 permutations, so AB itself is a permutation and BA, so you just change the position of each thing. So let's take another example where we have like three characters, right? A, B, C, right? So the permutations could be A, C, B, or ABC itself, and BCA, BAC, CAB, CBA. So these are all like permutations, right? So any of them can be a permutation for ABC. Like, so depending on the length of the string S1, there can be the number of permutations is higher. So if you say like 3 characters, right, there are like 6 permutations that are possible. When there is 2 characters, there is only 2 permutations that are possible. Likewise, there are 4 characters, more permutations. Likewise, it is the number of permutations are increasing for a given string, right? So now our job is to find a permutation of S1 in S2, right? So in this example, even if AB is existing in S2 or BA also exists, we need to return true. So it doesn't matter the order of the the characters in the S1, but even though the order doesn't matter, all those characters should be together. So that matters, right? So for example, if S2 was let's say ABC, right? So not ABC, actually ACB, right? Let's say if S2 was ACB. So even though A and B are there, but they are not together, we would return false still, right? Because A and B are there, but they are not together. A and B are there, but they are not together. ACB is there, right? ABC. If it is ABC or BAC or CAB, CBA, then we should have written false. But here in between A and B, there is C characters coming. So permutation is you need to have the same number of characters and they should be together and the same number of occurrences in the string S2. Then only we will say the answer as true, otherwise we will say false. So permutation is the same length and the number of characters should occur in the same number of times and they should be together. If all those 3 conditions are, so I have listed only 2 here, but those characters being together is like implicit, right? So those should be there. So that's why I listed only 2 characters for permutation. So they should be same length and each character occur same number of times. So what we are essentially going to do is we will build up a logic by using a hash table. Okay, so for the string S1, right, for the string S1 we will build a map. So map is nothing but how many characters are there and each character occurred how many times. So for example, if we build, I'm taking the example S1, right? So let's knock this off. Okay, knock the first line off, okay, and then have S1 as AB and S2 as eidbaooo, right? So S1 AB, our map will become A1 B1, right? So now, since we are given with two strings S1 and S2, first we already got the map for A1, S1, A1 and B1. So now what we are going to do is we will build a map for S2 as well, and we will build whenever the length of the map S1 and length of the map S2 is same, we will see their occurrences are also same or not, right? So there are two things. So they should be same length and occurrences same number of times, right? These are the two properties that we are going to use, right? So S1 is we build once, that's it. But S2 we keep on building and check if the length of S2 is same. And once we confirm the length of the S1 map and S2 map are same, we check if the characters occurred same number of times, right? And if so, we will say, okay, string is the S2 has a permutation of S1, we just return true then and there itself. We don't have to do anything else, right? So that's what is the logic that we are going to do. So let's go ahead and look at the example, the same example, right? So S1, this is S2 actually, and this is S1. So S1 is AB, S2 is AD. So S1 map, as we said, this is what is S1 map, right? So now let's build the S2 map. So I is equal to 0. This is the index basically. I is index, okay? Index for S2. When I is equal to 0, map will have the S map will have E1 because first character is E. So now the maps are not equal and not yet equal to the length of the second string S2, right? So if I is equal to 2, that means at I, right? So this one, E is 1, I is 1. E occurred once, I also occurred once. The maps are not equal. When I say not equal, right? So even though the lengths are equal, I am saying the characters occurred same number of times. This is getting false, right? That's why I am saying maps are not equal. So it's not just the lengths here. So when I say maps are equal, it should be same length as well as the same number of characters should occur same number of times. So maps are not equal. So what we are going to do, since the map length is 2 and the maps are not equal, we remove the oldest character. So what is the oldest character? E, right? Oldest character is E. So we remove the E1 from the map. So our map will become I1. So now we move the index I is equal to 2. So 2 is what? D. So our I is 1, D is 1. Still maps are not equal. So update the map, remove the oldest character I1. So when I am saying oldest character here, right, it depends on the length of the S1. So in this case, length of the S1 is just 2. So that's why we are removing always the first character, we can say, right? So update the map, D1 it becomes. So next, I is equal to 3. When I is equal to 3, we insert B. So D1, B1. Maps are still not equal. Update map, B1. So D is knocked off. And after B, it is A, right? So I is equal to 4, B1, A1. The maps are equal, right? So A occurred once, B occurred once, B occurred once, right? So now the maps are equal. We just return true. So if you look at the string, right, S1 is AB, right, but S2 is BA, right? So BA is a permutation of AB. That's what we learned, right? So the permutations of S1 are AB and BA. So even if BA occurs, we should return true. That's what we are doing right now. So maps are equal. When I say equal, they are having these two conditions satisfied. They should have same length and each character occurred same number of times, right? So that's what it is. So maps are equal and return true, right? So we return true for this particular thing, right? So let's go ahead and try to look at the code for this particular problem, right? So first, what we are going to see is for this permutations, the maps are equal or not. So it exactly follows this. So we are passed with two maps, right? So the map for S1 and map for S2, right? We are passed with two maps and we are checking if they are same length and each character occurred same number of times or not. So let's check whether the maps are equal or not. So that is the first function that we we'll look at, and then we'll come back to the main method. Okay, so this is check if maps are equal. So we are passed with two maps, A and B. Okay, so first thing is we need to check the length, the count. A dot count is equal to B dot count. If they are not equal, obviously it's not a permutation at all, right? But now that we are saying okay, they are equal, right, then we go further. What we are going to do is we are trying to compare each key and their corresponding value. Key is essentially the character, right, and the value is essentially the number of occurrences. The character should be existing and the number of occurrences should be same. If so, we are good, we don't have to do anything. Otherwise we return false, right? So once we go through the entire dictionary, the map, once we come out, that means all the characters are existing and their occurrences are also same. That means we return true. So that's what if the check map equals function will do for us. So let's jump back to the main function where it is getting called. This function is getting called to check the maps are equal or not, right? So now dictionary map, we are going to declare a map. This map is for S1, right? So first we are building the map for S1. So S1 is AB. So this map essentially we are building. So this for loop will build the map for S1, right? And then we declared another map called S map, that is for map S2, right? We will build the map S2 map. Okay, we start with 0th index and continue building the map, right? So if maps length, so if I is greater than S1 length minus 1, right? So basically we are waiting until the map sizes are equal. If the map size is equal, then we check if the maps are equal. If so, we just return then and there. We don't have to do any further processing. We just return true. Check if maps are equal. This is what the method that we saw earlier, right? Checking those two maps are equal or not. So if so, we just return true. That's it. We don't have to do anything. But otherwise, what we are going to do is we knock off the last element, right? With these two, with these 4 lines, we decrement the last number. I mean the oldest character count, and if the oldest character count is 0, we knock that off from the map, right? And we proceed in this for loop until it is S2 dot length, or if it returns true, right? If after exiting this loop, that means we are not able to find the permutation of string S1 in S2. What we should do return false. So the only case when we return true is when we check the maps and if they are equal, we return true. Otherwise we return false. So that's how this algorithm is going to work. It exactly follows the thought process that we discussed initially here, right? So check if maps are equal is getting called when the maps length, when the maps count is equal, right? So that's when we are doing it. So now let's go back to look at the time complexity and space complexity for this. So time complexity, right? So how much time we are taking, right? So this one is one for loop which is going through the length of S1, right? So each character in S1. So for this it will take length of S1. Let's say S1's length is M, right? S1's length M and S2's length is equal to M, right? That's what we will say. So this will go through order of M, right? That is the time complexity for the first for each. And next for, we are going through the length of S2. So the length of S2 is, we said, order of N, right? And so this for loop will take order of M plus order of N. And this calls check if maps are equal almost for every character after the length is greater than S dot length minus 1, right? So how much time this check if maps are equal is going to take is the question. So one note that we are given with here is input string contains only English lowercase letters. So how many lowercase English letters are there? There are 26 letters which are from A to Z, right? So A to Z. So that means this if check if maps are equal will be running through 26 times, right? So there are only 26 letters. So for each will execute only 26 times, right? So this will be the check map complexity will be how much? Check map. Check if maps are equal. Maps are equal, right? It will take order of 26 because it has only 26 characters, right? So that means for every n characters we have to multiply this complexity, right? So into 26 we would say, right? So what that becomes? Order of m plus 26n. So basically that is the time complexity we will say. So if you want to remove the characters from the big O notation, right? So the total complexity will be order of m plus n we would say, right? So time complexity for this particular algorithm will be order of m plus n. And space. So we need this piece of information again. Lowercase English letters, right? All the string contains only lowercase English letters. So that means 26 lowercase English letters. So how much space we will be using for the map? The map will store at the maximum of 26 placeholders, right? So that means order of 26 plus how much the S map will store. So at a given time S map will also have at the max 26 letters, right? Even though we are cutting down after the length of S1, right? So we are cutting down the size of the map. Still we could say at the worst case it would take order of 26, right? So that means it will be order of 52. So in general when we have numbers like 52, right, we would say those are constant time. So we will say it will be a constant time complexity, sorry, space complexity, right? So this will take a constant time, sorry, constant space and order of m plus n time complexity. So we just followed only based on the note that which is given here and calculated the time complexity and space complexity for this algorithm. If you have any further questions, please post them in the comment section below this video. I have posted this code to the GitHub repository in 2 languages, C# and Java. You can find the link in the description below this video. If you haven't subscribed to my channel yet, please go ahead and subscribe and also share among your friends. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem soon. Till then, stay safe and goodbye.